Hello everyone. Welcome to today's topic of discussion on AI versus ML versus DL, that is artificial intelligence, machine learning and deep learning. These are the terms which have confusing a lot of people. Let me resolve it for you. AI, ML and DL have become the most talked about technology in today's commercial world. Nowadays, many misconceptions are there related to the words ML, DL and AI. These are popular buzzwords that everyone seems to use nowadays. Here is an illustration designed to help us understand the fundamental differences between AI, ML and DL. AI. It is the concept of creating smart, intelligent machine. That is, ability of a machine to imitate intelligent human behavior. Machine learning. It is a subset of artificial intelligence that helps you build AI-driven application. Application of AI that allows a system to automatically learn and improve from experience. Deep learning. It is a subset of machine learning that uses vast volume of data and complex algorithm to train a model. Now, let's explore each of these technologies in detail. What is artificial intelligence? Artificial intelligence, commonly referred to as AI, it is the process of imparting data, information, and human intelligence to machine. The main goal of AI is to develop self-reliant machine that can think and act like humans. These machines can mimic human behavior and perform tasks by learning and problem solving. Most of the AI systems simulate natural intelligence to solve complex problems. On a lower level, an AI can be only a programmed rule that determines the machine to behave in a certain way in certain situation. So, basically, AI can be nothing more than just a bunch of if-else statements. AI is the broader umbrella under which machine learning and deep learning come. And you can see that even deep learning is a subset of machine learning. So all three of them, AI, machine learning and deep learning, are just the subset of each other. The term AI was first coined in the year 1956, but AI has become more popular these days. Why? Well, it is because of the tremendous increase in data volumes, advanced algorithm, and improvement in computing power and storage. AI is a technique that allows machine to act like human by replicating their behavior and nature. Examples of AI include speech recognition, image processing, problem solving, etc. Let's take an example here, Amazon Echo. It is a smart speaker that uses Alexa, virtual assistant AI technology developed by Amazon. Amazon Alexa is capable of voice interaction, playing music, setting alarm, playing audiobook, and giving real-time information such as news, weather, sports, and traffic reports. As you can see, the person wants to know the current temperature. The person voice is first converted into a machine-readable format. The formatted data is fed into the Amazon Alexa system for processing and analyzing. Finally, Alexa returns the desired voice output via Amazon Echo. There are various applications of AI. These are machine translation such as Google Translate, self-driving vehicle, AI robots, speech recognition application. Now come to machine learning. Machine learning came into existence in the late 80s and early 90s. But what were the issues with the people which made machine learning come into existence? Statistics. How to efficiently train large complex model. Computer science and AI. How to train more robust version of the AI system. Neuroscience. How to design operational model of the brain. So machine learning come into existence. Machine learning is a subset of AI. It allows the machine to learn and make prediction based on its experience. Experience means we can say that data. Machine learning is a discipline of computer science that uses computer algorithm and analytics to build predictive model that can solve business problem. As per Kinsey, machine learning is based on algorithm that can learn from data without relying on rule-based programming. How does machine learning work? Machine learning access vast amount of data that is both structured and unstructured, and learn from it to predict the future. It learns from the data by using multiple algorithms and techniques. This is a diagram that shows how machine learns from data. There are mainly two types of machine learning. These are supervised and unsupervised learning. In supervised learning, the data is already labeled, which means you know the target variable. Using this method of learning, system can predict future outcome based on the past data. The relation between the input and the output variable is known in supervised learning. Machine learning algorithm will predict the outcome on the input data, which will be compared with the expected outcome. Some algorithm, or we can say that examples of supervised learning include linear regression, SVM, that is support vector machine, NB, Navi Bayes, logistic regression, decision tree, and so on. Supervised learning can be separated into two types: classification and regression. Classification. These algorithms are used to categorize the given test data accurately. In this example, the algorithm is trained using labeled data of dogs and cats. The trained model predicts whether the new image is that of a cat or a dog. Regression. These algorithms are used for finding relationship between the dependent and independent variable. This is usually used for predicting and forecasting. Some algorithms include linear polynomial regression. Unsupervised learning. Unsupervised learning algorithms employ unlabeled data to discover patterns from the data on their own. The system are able to identify hidden features from the input data provided. Once the data is more readable, the pattern and similarity become more evident. It does not rely on trained data set to predict the outcome, but it uses direct techniques such as clustering and association in order to predict outcome. Some example of unsupervised learning include K-mean, hierarchical clustering, anomaly detection. This is the example of unsupervised learning method that trains a model using unlabeled data. In this case, the data consists of different vehicles. The purpose of the model is to classify each kind of vehicle. That is bus, car, truck. In this here, this is the unlabeled data. Data fed to the algorithm, learns the pattern in the data, train the model, and the purpose of model is to classify each kind of vehicle. Two common uses of unsupervised learning are clustering and dimensionality reduction. Clustering technique is for grouping the unlabeled data based on their similarity or differences. One of the popular clustering algorithm is K-mean clustering algorithm. K represents the number of groups. Dimensionality reduction refer to representing the same data using lesser dimension while maintaining its integrity. This is usually used while removing noise data from an image to improve its quality. These are the main differences between supervised and unsupervised learning. In supervised learning, input data is labeled. It is used for prediction and classification models. It takes direct feedback of the output. These models predict the output. It can be used in cases where we know the input and their respective output. In case of unsupervised learning, input data is unlabeled. It is used for extracting information from large amount of data. It does not have a feedback mechanism. These models find underlying patterns in data. We can use this model where we only know the input data and don't have the knowledge of the corresponding output. These are the main differences between supervised and unsupervised learning. And classification and clustering. There are various differences between classification and clustering. These are: in classification, number of classes is known. Training data is required. Based on the training data, classification model is used to classify future instances into already defined classes. Popular algorithms for classification include Navi-based decision tree, random forest. In case of clustering, the number of classes is unknown. No training data is required. Clustering is used to make sense of existing data. Popular algorithms used for clustering include K-mean, density-based, and so on. These are the differences between classification and clustering. Classification used for supervised learning and clustering is used for unsupervised learning. Classification process classifying the input instances based on their corresponding class label. In case of clustering, grouping the instances based on their similarity without the help of class label. In classification, it has label, so there is a need of training and testing data set for verifying the model created. In the case of clustering, there is no need of training and testing data set. Classification is more complex as compared to clustering. The algorithm used in classification are logistic, Navi-based, SVM, and so on. And the algorithm for clustering are K-mean, clustering EM, etc. Example of machine learnings are online chat, support by website, email messages, that is automatically detect whether the content is spam or not, marketing campaign. These are the example of machine learning. AI and ML. A large area of AI is ML. By this we mean that AI uses machine learning algorithm for its intelligent behavior. A computer is said to learn from some task if the error continuously decreases and if it is matches the performance is desired. Machine learning will study algorithm that will perform the task of extraction automatically. Machine learning comes from statistics, but it is not actually. Similar to AI, ML also has a very broad scope. What is deep learning? Deep learning is a subset of machine learning that deals with algorithm inspired by the structure and function of the human brain. Deep learning algorithm can work with an enormous amount of both structured and unstructured data. Deep learning core concept lies in artificial neural network, which enable machine to make decisions. The major difference between deep learning versus machine learning is the way that data is presented to the machine. Machine learning algorithms usually require structured data, whereas deep learning network work on multiple layers of artificial neural network. This is what a simple neural network looks like. Here, the network has an input layer that accepts input from the data. The hidden layer is used to find any hidden features from the data. The output layer that provides the expected output. Here is an example of neural network that uses large set of unlabeled data of eye retina. The network model is trained on this data to find out whether or not a person has diabetic retinopathy. Here images of eye retina fed to a neural network for training. New image of eye retina identify healthy and diseased eye. Artificial neural network has unique capability that enable deep learning model to solve tasks that machine learning model could never solve. It is a very young field of AI based on artificial neural network. Deep learning uses a multi-layered structure of algorithm called neural network. How does deep learning work? Calculate the weighted sum. The calculated sum of weight is passed as input to the activation function. Activation function takes the weighted sum of input as the input to the function, add a bias and decide whether the neuron should be fired or not. The output layers gives the predicted output. The model output is compared with the actual output. After training the neural network, the model uses the backpropagation method to improve the performance of the network. The cost function helps to reduce the error rate. There are various types of deep neural network. These are CNN, RNN, GAN and DBN. CNN is convolutional neural network. It is a class of deep neural network most commonly used for image analysis. RNN is a recurrent neural network. It uses sequential information to build a model. It often works better for models that have to memorize past data. GAN is generative adversarial network. These are algorithmic architecture that use two neural networks to create new synthetic instances of data that pass for real data. DBN is a deep belief network. It is a generative graphical model that is composed of multiple layers of latent variable called hidden unit. Each layer is interconnected, but the units are not. There are various deep learning applications. Some of them are cancer tumor detection, caption bot for captioning an image, music generation, image coloring, object detection. Why is deep learning better than machine learning? The main advantage of deep learning over machine learning is the needlessness of the so-called, that is, feature extraction. Long before deep learning was used, traditional machine learning methods were popular, such as decision tree, SVM, naive-Bayes, logistic regression. These algorithms are also called flat algorithms. Flat means here that these algorithms cannot normally be applied directly to the raw data. Raw data such as images, text, .csv, etc. In this, we require a pre-processing step. This is called feature extraction. Feature extraction is usually pretty complicated and requires detailed knowledge of the problem domain. This step must be adapted, tested, and refined over several iterations for optimal result. Deep learning models don't need feature extraction. These don't require the step of feature extraction. In this, the layers are able to learn an implicit representation of the raw data directly on their own. Here, a more and more abstract and compressed representation of the raw data is produced over several layers of an artificial neural network. This compressed representation of the input data is then used to produce the result. In other words, we can also say that feature extraction step is already a part of the process that takes place in an artificial neural network. During the training process, this step is also optimized by the neural network to obtain the best possible abstract representation of the input data. For example, if you want to use a machine learning model to determine whether a particular image shows a car or not, we humans first need to identify the unique features of a car, that is shape, size, wheels, etc. Extract these features and give them to the algorithm as input data. This way, the machine learning algorithm would perform a classification of the image. That is, in machine learning, a programmer must intervene directly in the classification process. But in case of deep learning model, the feature extraction step is completely unnecessary. The model would recognize these unique feature characteristics of a car and make correct prediction completely without the help of human. So deep learning is better than machine learning. These are the major differences between machine learning versus deep learning. Machine learning a subset of AI and deep learning is a subset of machine learning. Machine learning can train on small data set. Deep learning requires large amount of data. In case of machine learning, it requires more human intervention to correct and learn. In case of deep learning, learn on its own from environment and past mistake. Machine learning, shorter training and lower accuracy. And in deep learning, longer training and higher accuracy. Machine learning makes simple linear correlation. Deep learning makes non-linear complex correlation. Machine learning can train on a CPU, Central Processing Unit. Deep learning needs a specialized GPU, that is Graphics Processing Unit, to train. Thanks.